Hello and welcome to the end of your Avalanche module. So by now you've probably read the requirements and you're starting to think about how you might go about creating this. Now, sometimes when you're going through the details, it can be easy to make a project more complicated than it needs to be. And sometimes it can really help to have an example of what is expected, just so that everything is really clear when you're working on your project, right? So what I've done is I've created an example to demonstrate basically one way that you can complete your assessment. So what I'm going to do is just give you some of my thoughts as to why I made some of the decisions I made. And then in this way, when you go to do your project, you'll be able to have an easier time with it. Okay? So in the last lesson, you deployed a contract and you verified it. So by now you should already know how to do that. So at this point, I've already created my contract and I've deployed it to the Fuji test network, as you can see right here. You can also see I've done some test transactions here just to make sure everything is working. Always a good thing to do. And so I deployed this with hard hat, just like we did in the last lesson. But in order to test it in its deployed state, what I've done is I have opted to use Remix. Now, I've done this for a couple reasons. Now, one obvious thing that I could have done is create a front end, but it wasn't mentioned in the requirements, and sometimes creating a front end can be a lot of extra work. So since it's not required, there's no need to create extra work that we don't have to do, right? That said, I think a front end for this project would be really cool. So if any one of you decides to do that, awesome. And so because we don't have a front end, we're going to be testing this through a console, right? And so one of the easiest ways to test a contract is basically with Remix because instead of having to do console commands, when you load a contract in Remix, it provides you with these buttons, and all you got to do is push the button and get your output. So that is why I've opted to use that. And I'll show you exactly how to do that yourselves as well. So here, again, you see the contract, it's been verified and everything. So what we're going to need to do is, if you look here, we're in the deployment page of Remix. And when you're in Remix, you typically have two ways you can deploy a contract. So you can just press the deploy button here to deploy it to whatever environment that you've selected here. Or you could put an address in here, and then it's just going to load the contract from that address, right? Which is exactly what we're going to do in this instance. So what you're going to need to do is get your contract address, if you decide to do this yourself, and paste that in. And then here at the top, the default setting is to use the virtual machine. But that's not going to help us because our contract is actually on the blockchain right now. So in order to get access to it, what we're actually going to do is use our MetaMask, kind of like as a bridge to the blockchain. And in order to do that, what you want to do is select the injected provider here. And what's going to show up here is your MetaMask account. Now your MetaMask itself is going to have to be connected to the test network. I'm not sure if this will show for you, but as you can see, it's attached to or connected, I should say, to the Fuji network, which is also kind of shown here where it shows the chain ID of 43113. That's another way you could, yeah, you could kind of confirm it. So now that we have our provider set up and we have our contract here, all we have to do then is click this button that says Add Address, and our contract is now loaded up here. And as you can see, we've got all of our functions here. So to test this and interact with it, all we got to do is push some buttons. So, I mean, how cool is that? It's so easy. Which again, is why I opted to do this. You don't have to do it this way yourselves. This is just the way I decided to do it. So feel free to do this however you want, because like most problems, there's going to be always more than one way to solve it or to write a line of code. So always feel free to experiment and try other things, okay? So the requirements for this contract were to have a minting function. We need to be able to transfer tokens between players. Players need to be able to redeem these tokens for rewards. They need to be able to check their balances, and they need to be able to burn tokens. Now, how I decided to handle this is, of course, to load the sample project, because that's already going to have things sort of laid out for you. You're already going to have a minting function just out of the box. So you won't have to worry about that. So that's done, right? And then for transferring tokens, that is one thing I'll actually show you from this code, just to save you a little bit of time, because in a lot of examples, you'll see just the transfer function call being made. And how that works is if you were to call transfer here, essentially those tokens would have to be coming from the smart contract itself. But since the smart contract doesn't actually own any tokens, those tokens are in wallets, that command won't work, right? So in order to do this, or at least how I did it, what you would need to do is have an approve. And what that's going to do is for our sender, it's saying, okay, so this contract can use the funds of this sender, and the amount of those funds are going to be whatever this value is, right? So for instance, say you wanted to transfer 100 tokens. So then this would be message.sender 100. And then what that does is that basically gives permission to the contract to transfer those tokens on your behalf. Because again, the contract itself doesn't have those. You have it, right? So then once you give that approval, you can tell the contract to transfer from the sender, in this case, message.sender, the person that's interacting with the contract, and then send it to the receiver, and then whatever that value was that you approved in the step before. And that's it. So the contract is basically just going to take those tokens and then move them over to the receiver. And then I wrap that in a function here and added a require statement just to check to make sure, you're not trying to send more tokens than you actually have, right? We definitely don't want that happen. So that's how I handled transferring tokens. Now, redeeming tokens is a little more interesting because ideally you would want to have this functionality in a separate contract, right? So for instance, you would have maybe your dgen token contract here, and then you'd have a separate smart contract for your shop. And then you would feed in that custom token into your shop contract, so it basically would accept it. But that does complicate things a little bit, and it's not something that's covered in the course, which is why I decided to just do it all in one contract. And reading through the requirements, it seems like it wants you to keep things in one contract anyway. So what I've done is I've created a redeem tokens function, and how I decided to do it, because again, I just try to make things as simple as possible. So I created a function called show store items, which you can see here. And if you call that function, it just returns a string of all the items that are available in the store. Now, it's going to look a little weird here because it's not reading the new line characters. But you can see the first item that I have available is an official degen NFT because, people love NFTs. The second one is a t-shirt because swag. And then the third one is, to be honest, I don't remember what the third one is. But there's 3 items. And you can see that they're numbered 1, 2, 3. So now that we know what the store items are, we have our redeem token function here. We're just going to take the user's choice. So if you want an NFT, you would put in 1. If you wanted the t-shirt, you put 2. And if you wanted our mystery item, you would press number 3. And then, of course, each one of those has a different cost. For this, I believe I set the NFT to be like 100 tokens, and then the next one was 75, and then 50. But those are just arbitrary values. You can set that to whatever you want that to be. So we'll go ahead and, oh, actually we can't do this because we have to mint our tokens, right? But first, let's just show some of the other things here before we go ahead and mint. So if you click name, you see the token name is dgen, as shown in the sample project. And if we get the balance of the contract, you can see the contract itself has 0 tokens, which is expected. And the owner is, of course, the address that you used when you deployed this with Hardhat or whatever environment that you used. So when you go to mint, make sure you use that same address, or else it's probably not going to let you mint. In fact, it will not let you mint. If it does, something horrible has happened and you need to fix it. Okay, because that's not ideal behavior. We have our symbol, which is DGN. Total supply is 0 because, again, we haven't minted anything. And one other design choice that I made for this is I made it 0 decimals, just so it's easier to work with and I don't have to worry about it. So that just means, again, there's just no decimals, right? So you can transfer like 1 token, you can transfer 2 tokens, but you can't send like half a token, okay? Again, you don't have to do that, but that was just a design choice that I made just to simplify things. Okay, so now that we have that out of the way, the first thing that we need to do is mint some tokens. And so I'm going to go ahead and mint some tokens to a second wallet. Again, I don't know if you can see this on your screen, but I just copied a wallet address for a burner wallet. And staying on the, again, the same address that deployed the, oh, which, see, I already messed that up because I switched the account. So again, using the same address that deployed the contract, which we are on now, you'll go ahead and put in the address you want to send the minted tokens to, and then the amount. So in this case, I'm going to send 1,000. Then we'll hit transact. Now MetaMask is showing the transaction and what the gas fees are going to be. Go ahead and click confirm, which hopefully shows up, but it's probably not because That's how life is sometimes. And now it has confirmed. So if we go into our balance of function, which is the function we created to check balances, and we paste that in, we can see that there are now 1,000 tokens there. And extra cool, if we look at our contract now, we can see 35 seconds ago a mint function was called and all the details are right there, right? So if we load this up, we can see that this address initiated that mint function. It did that by interacting with this contract address. And then we can see 1,000 degen tokens, essentially going from the oblivion into the wallet that we put in. All right, so it worked. So now that we've minted, we can actually buy something, right? So now we're going to do the redeeming. So we said we were going to redeem for an NFT because NFTs are cool. So we'll go ahead and put in the option 1. We will transact. Oh, but of course, we're getting an error here because it's seeing that the account that we're on right now doesn't actually have any degen tokens. And that's because we did not switch to the account that actually has the tokens. So another pitfall to watch out for. Now that we have switched, we can go ahead and try this again. Sometimes it takes a moment for it to recognize that you are on the new account. Okay, so it looks like it just updated. So if we click now, excellent. So MetaMask is popping up, showing us the gas fee of 4 cents. Amazing. And Ethereum is probably like 20 bucks. We'll go ahead and confirm. And transactions confirmed. So again, we'll now go back to our contract. And when you're calling these functions yourselves, this is a nice thing to do. So when you actually do your functions, go back to your deployed contract and just make sure that, you can see the evidence of it working there as well. And there it is. So the method redeem tokens was called. We can see that it took 100 degen tokens and it sent it to the owner of the contract. That's because I just set it up that way. So for the contract I wrote, it's just going to send the tokens back to the person that deployed the contract. In reality, that might be corruption, and you might not want that to happen, but that's how it's working here. So there it is. So that works. For checking token balance, you kind of already saw that. And you can actually see that here as well. So I have two functions actually for checking balances. So I have get balance that just returns the balance of whoever is calling the contract. In this case, it'll be whatever account is here in this box. And we're doing this by calling this .balance of. Balance of is something that's built into the ERC20 contract, which is why we're able to call it. And this is basically just saying this contract, right? This contract that we're already in, call its balance of function. And then we're passing in message.sender, which again is just whoever is calling this contract. So whoever's calling the contract, get their balance and return it. But then I also have another one that takes an address, which works similarly, except obviously it's going to use that address that's provided instead of message.sender. Again, I'm not going to show you all the code because if I do, people will just submit our own code back to us, and that's not what we want. We want to see your unique original work on this. And so that's why I'm not showing everything. So yeah, so we have the balance function. And then the very last thing is burning tokens. Now, there's several ways you can go about burning tokens. One of the old school ways is to send tokens to address like 0x0, which is basically an address that no one can ever access, just throwing it into oblivion. But how I decided to handle this is, because it's already shown on the screen, is ERC20 has a lot of extended functionality that you can call upon. And one of those is something called ERC20 burnable. So when you import this, and then you add ERC20 burnable to your contract, it's going to automatically add 2 burn functions for you, which is awesome, right? Because now you don't have to do anything but call those functions that have already been created for you. Which is another thing that's nice to mention here, because when you have an opportunity to use a solution that already exists, make sure it's open source and you're allowed to use it in your work. But if something like that exists, use it, right? Because a lot of times there's no reason to reinvent the wheel. So if it's a simple problem to solve and it's been solved a million times already, use the provided solution. It's going to save you time. You know it works. You know it's secure. There's really no reason not to use it. And that is the reason why I chose to use this, because it's already built into the contract. So why not, right? And to show you that that actually works, so we're still on that other account that has the tokens, and we spent 100, so we should have like 900 tokens left. So now if we go into this burn function here, and we punch in 900, we got MetaMask loading up, showing our gas fee. Hit confirm. And any moment now, it will tell us that tokens have been destroyed. So we'll just wait on that for a moment. Oh, then there it is. So the tokens have been burned. Fantastic. So now we have to confirm that actually happened, right? So the easiest way to do that would be to call our get balance, I believe is what we called it. Yeah, get balance. And now we can see that we are back to 0. And if we do our balance of again, we can see that's 0 as well. And then lastly, we check the contract, and we can see a burn happened, and it was for 900 tokens. And you can actually see what I mentioned earlier here as well, about how you could just send those tokens to a zeroed out address. It looks like that's actually how this contract handles that. So that's just proves that I was right about that. So that's nice. So I believe with that, that should give you a pretty good start as to how to go about this. And as you can see, it doesn't have to be complicated. You can make it, like most projects, you can make it as simple or as difficult as you want to. Especially when it comes to the shop, I believe for most people that's where a majority of the complexity is going to be. Again, for me, I chose to handle that with just passing strings and using IDs to return a string back, showing what that reward is. But of course, I encourage you all to do something more impressive than that, if you can, if you have the time. If you come up with a front end, amazing. If you decide to incorporate an NFT contract into this and actually generate an NFT, that would be exceptionally cool. I really look forward to seeing your submissions. I hope this has helped to bring some of the stress levels down. And if you have any questions, you can reach out to us on Discord. I am Pure Mentor Chris, and good luck